Hello again, Tom from Every Step Calculus, everystepphysics.com. We're going to knock this one out. Here's a calculus problem somebody submitted on Yahoo, and so I want to show you how my programs would work on this. This is a U substitution. The idea behind U substitution is that whatever in the parentheses here, we got brackets here because of the inside parentheses, and the derivative of whatever's inside here, you're trying to match the outside, so you can get rid of this and this, the dx and the secant squared 3x. So you do that by identities, and in your calculus book, you know, around 143 pages or something like that, is they give you a list of trigonometric derivatives, identities for these, convert these, okay? And of course you notice how worthless this whole thing is. I mean, absolutely nonsense, but that's what calculus is. It's all just a million puzzles that you're supposed to work out. And I say after 27 years, calculus solves nothing useful. Absolutely nothing useful. In electronics, no matter what you look at, it just solves nothing useful. And I'm a electronics major guy. Index 8 to get to my menu. Well, first thing you got to learn is that whenever you have these kind of things, generally the first thing you think about is integration by parts, okay? Unless you're a genius and know these derivatives in here, but so that's what we're going to look up in the menu, and then I'll take you from there, okay? My program decides whether it's a U substitution or integration by parts problem. So index 8 to get to my menu. I'm already at integrate by parts, save time. And I ask you, is secant in the function? Well, yes it is. Okay, so we're going to answer yes. That takes you to the different test problems on secant and tangent, okay? So what we're looking for is secant squared 3x divided by 1 plus 4 tan 3x. Okay, so we don't see it here right now, so we're going to scroll down a little bit more. And you notice here A is secant squared 3x, and here is divided by 1 plus 4 tangent 3x. I have to do it in the menu here because if I put that all together, it would go past and wouldn't allow me to work in the calculator, so I have to separate it here. You have to know a few things, get used to my programs, get used to what's happening. But anyways, we went to integration by parts, right? So and if you clicked on either one of these, A or B, it would take you here. This is integration. I equals integration equals the integral of secant squared 3x. Here's the function in here, okay? So we let u equals 1 plus 4 times tangent of 3x, okay? And now we're going to find the derivative of that with respect to x dx. And so the derivative of 1 is 0, and the derivative of 4 times tan of 3x is 3 times 4 is 12. Secant squared 3x, okay? So we found the derivative. Now here's the trick in U substitution that I've always found. Any constant like this you take out of this section here, right? And so you move that to the other side, so you got du divided by 12. You take the dx and put over here on this side. Okay, so you got 12 over here, and notice that secant squared 3x dx matches secant squared 3x dx in the function. So that cancels the numerator. So we rewrite with regard to u. Integration equals the integral of 1 over u, and then we have du divided by 12, right? And In integrals, you got to bring the constants outside of the integral, so it's 1/12 outside times the integral of 1 over u. Anytime you see 1 over u or 1 over anything, it turns into a log answer, okay? So then when you integrate, it's 1/12 times the log of u plus c. And then we back substitute 1/12 times the log of 1 and put in the what u equaled here plus c, and that's the answer. Okay? So anyways, go to my site, buy my programs, and pass calculus, or notice what you had to go through to do this. However, I don't think this would ever be on a test. I just did it for people in case they have homework or something like that, you know. But mainly tests have to be relatively simple, because otherwise the whole class will flunk it, you know. And because all calculus and physics tests are scored on partial credit in the class curve, so whatever you can throw down on a test paper that's meaningful to the problem, you get certain points for that, several points, and you're trying to get a few points, a number of points, and then hope that there's not a person from India who studies this stuff from the age of 3 in your class to screw up the class curve, okay? I mean, I got an A one time in a physics test and I got 26. So class curve and partial credit, keep that in mind, okay? And certainly you got the problem right on this one, you know. Hey, have a good one. Subscribe if you want to, and share this with somebody else. Maybe they'll buy the programs too, who knows. Have a good one. Good luck in your classes.